Everybody, this is Jono from Seneca. Today, for this revision episode, I'm going to be going through calorimetry for your chemistry A level exam. So I hope you're getting ready to be warmed up. It's a really important topic. The experiment comes up a lot in exams. You probably would have done it in class. So this will hopefully be a nice consolidation of it. Let's dive in. What is calorimetry? Well, it's used to physically measure changes in enthalpy. Bomb calorimetry uses a machine called a bomb calorimeter to measure enthalpy changes of combustion. This process involves burning a sample of a compound in a sealed vessel and measuring the temperature change. Often, the calorimeter will just determine the temperature change in the vessel, and you will have to calculate the enthalpy change of combustion. So there is some inaccuracy because bomb calorimetry can have certain things go wrong. So heat can be lost to the surroundings. Some incomplete combustion could take place, and some of the reactions could be lost before they are combusted. So there are some inaccuracies with bomb calorimetry. Now, if we want to calculate the enthalpy change, we can use the following equation. Q equals mc delta T. Now, what do all those things stand for, I hear you ask? Well, I am glad you asked. Q is the enthalpy change, M is the mass of the sample, C is the specific heat capacity, and delta T, which is like triangle T, is the temperature change. The pressure is constant in this experiment. So how do we calculate enthalpy changes? Once we've calculated Q, that tells us the energy given off to the surroundings, and the units of Q are joules. To determine the enthalpy change of combustion, we must convert joules into the unit of enthalpy change, joules per mole. So to do this, we calculate the number of moles using the formula moles equals mass divided by mR. And then we can calculate the enthalpy change by doing Q divided by the number of moles. Easy peasy. So do we remember some sources of errors in bomb calorimetry? Well, we've got heat loss to the surroundings, possible incomplete combustion, loss of some reactants as it evaporates before it combusts. Those are three to remember. So let's get into even more detail about calorimetry because there are different types. Calorimetry can be used to measure other enthalpy changes. We've considered the combustion reaction that gives off heat, but we can also measure any reaction that can be done in a sealed vessel. For example, you can measure the enthalpy change of neutralization of an acid-base reaction. These reactions take place in a solution that can be inside the vessel. Accurate temperature changes. You might think that the best measurements to record are the initial and final temperatures of your calorimeter, but this is not the case. This is because heat is always being lost from the calorimeter, so the final and initial temperatures are actually inaccurate. Instead, measure the temperature loss after the reaction is complete and extrapolate a line to find the true value. So that's what we need to do. You need to extrapolate the line to find the true value. So don't just read the initial and final temperatures. And why are the initial and final temperatures inaccurate? It's because heat is always being lost from the calorimeter. So should we go through an example? So let's say we burn cyclohexane, and that's a really good fuel. It's great, one of my favorites. And we burn it, and there's 200 grams of water in the calorimeter, and we burn 0.5 moles of cyclohexane. And the temperature of the water goes from 298 K to 368 K. So what we're going to do? So we're going to use our calculation Q equals mc delta T. Now there was 200 mils of water, which is equal to 200 grams. So our mass is 200. C is always 4.18 joules per gram per K. And this is because that's the specific heat capacity of water. So as long as you're heating up water, we use 4.18. And then we multiply that by 70K. And altogether, this will give us 58,520 joules. Now, if you remember, we've got to divide by the amount of moles. So that was 0.5, which will give us 11704 joules per mole. Now, we have to decide whether we put a minus sign or a plus sign. Now, the reaction, if you remember, the temperature went up, that means it's exothermic, and if it's exothermic, we put a negative sign. Now, to get the final answer, 117,040 is quite a big number, so we're going to convert that joules per mole into kilojoules per mole, and that will give us minus 117 kilojoules per mole. So that was a cute little example of going through how to use Q equals mc delta T, and then how you adjust for the amount of moles. Remembering to switch to kilojoules can be important, and always check the question to see what units they want the answer in, because sometimes that can be a mark, and you don't want to lose that mark in the exam. So we've considered calorimetry of combustion reactions. Remember, combustion reactions when we burn a chemical in a calorimeter and we measure the temperature change of a surrounding volume of water to determine the enthalpy change. We also thought about solution-based reactions, and that's when we can determine the enthalpy of different types of solution-based reactions by measuring the temperature change of the solution itself. So a good example of that is neutralization reactions between an acid and a base. So that was a run through of calorimetry. I hope that was a useful episode. Thanks for joining me and for being productive on your work and listening to this episode and being all great and being proactive in your learning. It's really good. Join me on the next episode. We're going to be talking more about energetics, and good luck with your studies.